We're talking about figures that have exactly the same size and shape. So congruent figures are when two figures have exactly the same size and shape, which also means same lengths and angles, because it's both sides, lengths, and the angle degrees that make up the shape. Does everybody know what that IE stands for? It's like Latin for examples. Okay, so when we have congruent figures, what we're going to end up with is something that's called corresponding parts. Now, you've heard the word corresponding angles before, last chapter. What do corresponding angles look like? They're in the same location, right? So that's kind of the same thing that has to do with corresponding parts. For corresponding parts, we're looking for matching parts of congruent figures. So matching parts of congruent figures. So we're going to have corresponding sides, and we're going to have corresponding angles. So when you are asked to list all the corresponding parts, you're going to list all the corresponding angles, and you're going to list all the corresponding sides. All right, so after we have that jotted down, our first example gives us two congruent triangles. We're going to write a congruent statement, and then we're going to write out the corresponding parts. Now remember, a congruent statement is something such as line segment KM is congruent to line segment TS. Okay, so you're stating that one thing is congruent to another thing. So what do I have here? What are my figures? My figures are two triangles. I want to state that those two triangles are congruent. So someone name this triangle to me. Put these letters in any order. What do you want to do? Triangle CAB. All right. So if we say triangle CAB, that's going to be congruent to. Now what's important when you write your congruent statement is you need to match up the corresponding parts. C is this angle right here with two angle marks inside of it. What angle over here would be the corresponding part of angle C? H. Does everybody see that? It's the same thing. So I'm going to make sure I do same order. A in this triangle is the right angle. What's my right angle over here? F. Good. And then we would be left with the last option, which is G. So my congruent statement is saying that triangle CAB is congruent to triangle HFG. Okay. Once you have your congruent statement, then identifying the corresponding parts make it really easy. So let's do our corresponding angles first, because they're probably the easiest. So angle C would be congruent to angle what? H. Good. Notice that C and H are the first letters of both of my triangle names, C and H. If I look over at the diagram, C and H have the same markings inside of them. What would be congruent with angle A? F. Notice they are both the right angles, and A is the middle letter here, F is the middle letter there.
And B would be congruent with G.
Good. Angle B is congruent to angle G. Do I have all angles? Yes. So now let's do corresponding sides. So someone give me a side on triangle CAB. CA, that would work. So line segment CA would be congruent to which line over here? Now be careful. Thank you for making that mistake, Miranda. If we're going to go C to A, then we're going to want to go H to F. So you have to watch your order. So if I'm starting with C, then I need to start with H. Though FH is the correct side, we want to write it in corresponding parts. So FH. Notice CA matches up with HF. Okay? So once you have your congruent statement, then it's easy to pull them apart. All right, give me another side over in this triangle. AB. So if I go AB, what will be congruent to AB? FG. Notice AB, FG. And then our third side that we don't have yet, it would be CB. What would be congruent to CB? HG. Good. So even if I didn't have this diagram and I was only given this congruent statement, I should be able to get all my corresponding parts. C matches up with H, A with F, B with G. Done. Sides. CA with HF, AB with FG, CB with HG. Okay, so given a congruent statement, you should be able to get all of your corresponding parts that easily. Okay, questions with that? We're good? All right, so now what happens if I'm given a congruent statement? So here we have a quadrilateral. There's no fancy symbol for quadrilateral because they all can look different. So we've got four-sided figures that are congruent. I'm given corresponding parts, but now my corresponding parts actually have either degrees to them or side lengths to them. And I need to find values of x and y. So let's first focus on part A. Find the value of x. So where do I have an x involved in this diagram? Angle W has an x in it. Also, side WX has an x in it. But notice this x also has a y in it. So that's not really going to help me out because it has two unknown variables. So let's focus here first.
Angle W is equal to angle W.
Yeah, so we know that angle W is congruent with angle Q. If you weren't aware of that, look up in your congruence statement. W corresponds with Q. So we know that they're congruent. Well, because they're congruent, now this is more work than you're going to need to do, we know that the measure of angle W is equal to the measure of angle Q. Right? We were thinking about this systematically by writing a proof. This is given to us. If angles are congruent, then their measures are equal. What would be our next step? Which property? Well, what is the measure of angle W?
5x plus 5.
What is the measure of angle Q?
65.
65. So if I was doing this in a two-column proof, what would be my reason over here?
Substitution.
Substitution. Very good. What would be your next move?
Simplify.
Not yet.
Subtraction.
Subtraction. 5x is equal to 60. Then our next move would be divide, which would be 12. Okay. Do you need to put this in? No. If I had to write a formal proof, then yes, we would need to do all those steps. So if x is equal to 12, how could I find the value of y?
QR is equal to WX.
Yep, so we know that. Can I erase this? Because I'm going to run out of space. I don't want you guys looking down. So we know that QR is congruent to WX. That's given to us. And since they're congruent, we know that the lengths are the same. Notice the difference between these two things. This is saying that they're congruent. This is saying that they are the same. Well, what is QR's length? 6. What is WX? Y minus X, but what is X?
12.
12. So that's kind of like a double substitution going on. Next move.
Add 12.
So we get Y is equal to 18. So we got Y is equal to 18, and we said that X was equal to 12. Done. Isn't that lovely? All right, the last thing we're going to do today is example 3. We're going to save the proof for tomorrow. So we've got a theorem that we need to get written down, which is called the third angles theorem. And what the third angles theorem says, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent.
Just with each other.
Right, so this is kind of like a no-duh situation. Let's make actual degrees up to make this make sense. So let's say that the measure of angle A is 50 degrees. And let's say that the measure of angle B is 100 degrees. What will be the measure of angle D? D. D would be 50, right? E would be 100 because they're congruent. Well, what does C have to be? You guys said it earlier. That would be 30. What would F have to be? 30. So is it true then that C is congruent to F? Yes. That's what the third angles theorem says. It's kind of like, well, yeah, that just kind of makes sense. It's what has to be left over. So if A is congruent to D and B is congruent to E, then we can justify that C is congruent to F because of the third angles theorem. Okay? So if we see that in action in example 3, notice we have two overlapping triangles. Sometimes it's kind of hard to see the overlapping triangles, but they're kind of overlapped on top of each other. If I pulled them apart, you don't have to do this. My triangles would be T, W, and S. Just watch, don't put this in your notes. This would be T, W, and V.
Oh, they're overlapping.
Yeah, do you see how they're overlapping?
Oh, I thought there were two triangles.
So it's like if I took these two triangles and then slid them over. So notice that the bottom side of each is WT, just in different orders. Does everybody see that? So where are my congruent angles? Well, I guess we have overlapping, but I guess that's not the one I really want to be looking at. So maybe I took you guys in the wrong direction. Maybe it's simpler than that. Here I have a congruent angle. If that's 66, what's this angle have to be? 66. I think I steered you in the wrong direction. I think what we're looking at is these two triangles, which is what you were probably looking at, right, Seth? Yeah. So if that's 66 and that's 66, where's your other set of congruent angles?
44.
So this would be 44 because you're vertical, right?
And then S and V are 70.
Yeah, so then how would you find V? Adam. So 66 plus 44
110.
is 110. Subtract that from 180. Gets you 70. So that means V and S is 70. So we could have gotten there just by finding S and then concluding that V is congruent to S. But either way, it gets you to the same answer. Okay? Once you have that, grab yourself a practice space. We're going to try some problems out and make sure we've got this covered. I guess I should. Huh? Yes, just sign out, please, Seth. Alright. First up, if I give you a congruent statement, can you identify all the corresponding parts? So triangle TSW is congruent to triangle MNO. So identify all 6 corresponding parts.